Now we will start after a few minutes. Would you please to remind me in what place we have end last time? What's the last task which we have solved? We have calculated the determinant, yes? And the last task was number, do you remember? Let's consider the next topic, which we have used under investigation of the analytical geometry. It's required us for define some rules of them and some for investigate the connection between the vectors in the plane or in the space. The system of linear algebraic equations. So SLAE is as follows. A sub 1 times x sub 1 plus etc plus a sub 1 n times x sub n equals b sub 1 etc a sub m1 times x1 plus etc plus a sub m n times x sub n equals b sub n. So name system of ordinary algebraic equations. Let's introduce the matrix A. A equals a sub 1 1, a sub 1 n, a sub n n, a sub m n. So name matrix of system. Matrix of system. Let's introduce the column B equals b sub 1 etc bn bm. bm. It's so name column of the arbitrary terms. Arbitrary terms. The column of arbitrary terms. With 8 of the matrix A and x equals x sub 1, x sub m, n, so name column of independable variables. The column of the independable variables. With the 8 of the A, B, and X, we can rewrite our system in the following form. A times X equals B. Suppose that A is square matrix. n times n. In this case, we can define the determinant delta is equals determinant A. So name determinant of the matrix of system, of the matrix of system. If delta is not equal 0, then the system have the only solution. That we can define using so named Kramer rules. That we can define the Kramer rules, namely consider the determinant delta E equals determinant matrix which we can receive by change the J column of the matrix of system by the columns of arbitrary terms, namely delta I sub I equals determinant following matrix A sub 1 1, A sub 1 I minus 1, B 1, A sub 1 I plus 1, A sub 1 n, etc. A sub n1, A sub n I minus 1, B sub n, A sub n I plus 1, A sub n n. So instead of the E columns of matrix E, A, we have write the columns of arbitrary terms, of free terms. In this case, the solution of the system of equation can be found by the formulas. In this case, the solution of these systems Ax1 equals B, x sub I equals delta sub I over delta. I is equals 1 etc n, 1 etc m. It's so named Kramer's theorem. So let's consider a simple example of the application of these rules. Let's consider simple examples of application of these rules. Consider the system of the equation x1 plus 2 times x2 plus x3 equals 4. 3 times x1 minus 5x2 plus 3x3 times x3 equals 1. And the last equation, 2 times x1 plus 7 times x2 minus x sub 3 equals 8 equals 8. Let's try to write the system of matrix of system. I hope somebody from the room can help me. For instance, you. Yes, matrix of the system. 1, 3, 7, minus 1. Column of the arbitrary terms, B equals 4, 1, 8. Column of the independent variables, x is x sub 1, x sub 2, x sub 3. Let's calculate the determinant of this system. Let's calculate the determinant of this system. Delta equals determinant A equals 1, 2, 1, 3 minus 5, 3, 2, 7, minus 1. What's your propose? How to calculate this determinant? Tell me. Maybe you can say? Yeah. Yes. How calculate this determinant? We can use the properties of the determinant or very difficult, the rules of triangles. Maybe you can? No, yeah, yes. Let's try. Yes, I will go to the blackboard. Of course, I will help you in this calculation. Yes.
May I use the rule of triangle, please?
Yes. 3 times minus 5 times minus 1 plus 3 times 7 times 1 plus no, plus 2, 2, 3. 2, 2, 3. Minus but simultaneously I will calculate this determinant using the properties of the determinant. So minus, let's try, let's check, minus 2, 3, it's right, tak?
Yeah.
Yes.
It's further,
Next, no. 3, 2 minus 1. 3 minus 1.
Okay.
Minus 1 and minus this. 1, 3, 7. And calculate, please. What's your name?
Đức. Phan mà Đức. Phan. You can call me Phan.
Farm?
Phan.
During the farm calculation, I will calculate, please continue. I will calculate some simultaneity using the properties of the determinant for check his result. Mine equals 33. Yes, it's right. Excellent. But I can demonstrate once again the more simple method, namely, let's multiply the elements of first row by the 3 and subtract from the second row. What we have? The first row is the same, 1, 2, 1. Second row, 0, minus 5, minus 6, minus 11, 0. Let's multiply the elements of first row by 2 and subtract from the third row. 0, 3, minus 3. Then let's factorize this determinant using the second row. Equals minus 1 power 1 plus 1 times minus 11 times 1 minus 1, 0 minus 3 equals minus 11 times minus 3 equals 33. Of course, the same result. So, the determinant of the matrix of system delta equals 33, not equals to 0. Then we have the only solution. To calculate all independent variables, we can calculate the determinant delta sub 1, delta sub 2, delta sub 3. By definition, delta sub 1 equals, we have changed the first column of the matrix of system to the column of the arbitrary terms, namely, using the properties of the blackboard, I write here 4, 1, 8. Let's calculate this determinant. I hope to calculate with the aid of the student from the room. Maybe you try.
But I didn't understand the triangle. I need
You see,
how to calculate the triangle.
you can calculate using or triangle rules or the properties of the determinant.
I want triangles to learn it because I didn't understand.
You don't understand how you can calculate the determinant or how can receive it?
How to calculate this triangle rule.
Of course, I can repeat it, but maybe you can use the properties of the determinant or not. You see, I will repeat the triangle rules. Determinant this kind is of third order, a sub 1, 1, a 1, 2, a 1, 3, A21, A22, A23, A31, A32, A33 can be calculated using the following formulas. A sub 1 1 times A sub 2 2 A times A 3 3 plus A 2 1 times A 1 3 times A 3 2 plus the next triangle A sub 1 2 times A sub 2 3 times A 3 1 and minus product of the terms on the co-diagonal minus A3 1 times A2 2 times A1 3 minus these triangles. Product of the terms from these triangles. A sub 1 1, A3 2, A2 3 and minus terms from here. A2 1, A1 2, A3 3. Let's try. Four times minus 5 times minus 1 plus 1 times 7, yes, plus 2, symbolical, yes, times 3 times 8, yes, minus 8, yes, minus these triangles. 4, 3, 7, minus this 2, 3, 8 equals but simultaneously I will calculate it, this determinant using the rules of the determinants, the properties of determinants. Answer 7, yes? Let's check. No, a little mistake. Not 7. Okay. 8, 7 minus.
17.
Now,
55.
let's try. Let's check. 4 times minus 5 minus 1. Where is it? 20, yes, plus 7, plus, yes, so 48, minus
Minus this.
84,
Yes.
mind is escape,
Okay.
and
It's 4. Minus 4.
yes,
Okay, so even.
no. I see, I know the answer, you see. We have to receive 33.
33.
Yes. There is mistake. You will check your solution. I will solve using the properties of the determinant. Minus 1, minus 5, 3, 0, 0. So, no. Minus 40. Plus now, plus 47. Minus 30. Not good. Not good. Let's try. It's not coincide with the answer, but maybe there are mistake here. Let's calculate oneself. So, equals 4 times minus 5 times minus 1 plus 1 times 1 times 7 plus 2 times 3 times 8 minus 1 minus 5, 8 minus 4 times 7 times 3 and minus 1 times 2 times minus 1 equals 20 plus 7 plus 48 plus 40 minus 12 times
7 times 3 is 28. 21.
21, yes, 84 minus plus 2
That's different. Here. Mistake. My mistake is here.
plus. So, what we have 27, 29, yes, plus 4 equals 33. Yes, I see. So, delta sub 1 equals 33. Delta sub 2. In this case, we have to change the second column of the matrix of system by the column of the arbitrary terms, namely 1, 3, 2. Here 4, 1, 8, minus 1. Let's try to calculate. The next student, please. Who want to try? Maybe you? Let's try. So, when we have write the system of linear equations in the matrix form, namely A times X equals B, we can write so named extended matrix of systems. A, B equals A sub 1, 1, etc. A sub 1 n. A sub m 1, etc. A sub m n. Let's simply write in the right hand the column of the arbitrary terms b1, bm. And usually in the problems, in the list of problems and tasks, at the beginning we have given the extended matrix of system. Extended matrix of system. And the topic, the task is the following. To write the system of linear equations which correspond to the extended matrix of systems. It's task number 70.2.4 from this book. 70.4. Given extended matrix of systems, namely A 2, 0, 9, C 55. It's not the size of matrix, it's not the size of column. It's the number of the matrix in the bank of the matrix at the end of the textbook. So, we have to find matrix number 209, 209, One minus 3 minus 1 minus 2, 7, 2, 3, 2, minus 4, and C55, C55. Column 55. minus 4, 10, 9. So, given through name extended matrix of system, the first task to write the corresponding system of equation. Who will to try? Who will try? Maybe you try. I don't know your name, unfortunately. After you. Yes. Maybe try? Let's try. The first task, to write the corresponding system of linear equations. Take, please. What do? At the beginning, we have to write the system of the equations, like this. Yes, it's first task. x1 minus 3x2 minus x3 equals minus 4, exactly. Minus, yes, plus 7x2 plus 2x3 equals 10. 3 times x1 plus 2 minus 4x3 equals 9. Excellent. So, the next problem to solve this system, yes? Let's calculate the determinant of the matrix of system, delta. Maybe you can use the right blackboard. Поверните просто чуть камеру, чтобы было видно. One minus 3 minus 1 minus 2 7 2 3 2 minus 4 equals I hope that all students are calculating this determinant together with us. So minus 28, yes, plus 4 minus, yes, 18 minus plus 20 plus 21, yes, minus 4 and plus 24. One moment, please. Minus 2 minus, yes, minus 2, no, plus, no, 4 minus and 6 times 4, 20, no, 24.
Yes.
Understand, yes? Minus 2, minus 3, minus 4, and another one. Plus, yes. So, not equal to not equal 0, yes? Consequently, exists the only solution. Its symbol denote exist. This symbol denote the only. Yes. The only. So name quanters. So then we can calculate this solution using Cramer rules. Yes? Maybe you, maybe another one student. Let's try. Delta sub 1 equals. We have to change the first column of the matrix systems by the column of arbitrary terms, yes? Minus 4, 10, 9. 3, 7. Equals. Please write all calculation on the blackboard. And please write all calculation in your paper. Not in the mind. Please write all. Right. You see, you have to write all. You have not to calculate in mind. To write. Who calculate this determinant? Delta sub 1, yes.
No, delta without sub 1.
Difficult. Using the triangle rules is difficult here, in my opinion, of course. Much more easy to use the properties of the determinant. For instance, multiply the first rows by 2 and add to the second rows. What we have? We will have 2, 13, 0. Then multiply the first rows by 4 and subtract from the third row, yes? I'm not sure, because usually in the task from the problem books, the results must be a little simple. If you have received such big number, it's the sign that there are a little mistake. Let's check. Delta sub 1 equals. You have to check your solution. I will check your solution, yes? Minus 4, 3, minus 1, 10, 7, 2, 9, 2, minus 4. Let's multiply the first rows by 2 and add to the second row. What we have? Minus 4, 3, minus 1, 2, 13, 0. Let's multiply the first rows by 4 and subtract from the third row. Minus 6, minus 16, 9 minus minus 16, it's 25. 2 minus 12 minus 10. And here 0. Then we have factorized by the third column equals minus 1 power 1 plus 1 times minus 1 times the determinant of the matrix which we have received escaping the first rows and in the second column. 2, 13, 25 minus 10 equals minus 2 times minus 10 minus 25 times 13 equals minus 5. Here minus 4 minus 65 equals
in the first column, the element 2, 1. Not trace means 4, 3, 1.
1 moment, please. Minus 4, 10, 9. Yes? Minus 3. Minus 3. 7, 2. I see. You see, you mistake here. Minus 3 here. So, and I repeat your mistake. What we have? We have minus 4, minus 3, minus 1. Then multiply these rows by 2 and add to the second rows. 2, 1, 0. Multiply first rows by 4 and subtract from the third row. For 25 minus 12 plus 2, 14, 0. Equals minus 1 power 1 plus 1 times minus 1 times 2, 1, 25, 14 equals minus 28 minus 25 equals minus 3. Delta sub 1 equals minus 3. So, No. Let's try once again using triangle rules. With my 8 equals minus 4 times 7 times minus 4. Yes? Plus 10 times 2 times minus 1. Plus minus 3 times 2 times 9. Yes? Minus 9 times 7 times minus 1. Minus 2 times 2 times minus 4. This triangle, yes? And at least minus 10 minus 3 minus 4. Please calculate it. And I think who received the delta sub 2? Delta sub 2. Who try? Maybe you? Yes. As you want. As you want. Yes. 1 minus 2 first column. 1 minus 2, 3. 1 minus 2, 3. Then we have, I have to say, we have changed the second column of this matrix by the column of the arbitrary terms. Minus 4, 10, 9. This minus 1, 2, 2, minus 4. And calculate. No, it's not possible because too big number. Understand? Let's calculate together. Let's calculate together.
56.
One down. 70. It's 16 times 7. Yes, 70. 112. Yes. Minus 20 plus значит, minus 6 times 9.
54.
Yes, minus 54. Yes, plus 63. Yes.
63.
Yes, it is, and plus 4 plus 8. Plus 8 and
60.
yeah.
2, 4. 16.
6. Yes, 16. You're right. And here 120 minus 120 equals. I have to calculate how to calculate easy. Easy. Maybe minus 8, yes. Minus 24 plus 74 73 and 79. So 71 minus 74 equals minus 3. Yes, the same result. So, what's answer? Minus 2? I think it's right. And the last determinant. Please go to the blackboard. You. I think you will satisfy. Delta sub 3 equals, yes, minus 372, and minus 4, 10, 9 equals. How we will calculate? By triangles rules or by the properties of the determinant? Yes, property is much more easy. Let's try. I will help you. Multiply the first rows by 2 and add to the second rows. Yes? First row without changes. Yes. Multiply by 2 and add to the second row. 0, 1, 2. Multiply by 3 and subtract from the second row. 0, 11, 21. Yes, equals. Yes. 1, yes. 1, yes. Minus, yes. Equals. Yes. Equals minus 1. Excellent. So, what we have? We have delta sub 1 equals minus 3, delta sub 2 equals minus 2, and delta sub 3 equals minus 1, and delta minus 1. Yes? So we can receive the solution of this system of linear equations. X sub 1 equals delta sub 1 divided delta equals minus 3 divided minus 1 equals 3. X sub 2 equals delta sub 2 divided delta equals minus 2 over minus 1 equals 2. And delta 3 equals, or x sub 3 equals delta sub 3 over delta equals minus 1 over minus 1 equals 1. So x1 equals 3, x2 equals 2, and x3 equals 1. We can check our solution. How? Let's substitute this x to the first equation of the system. 3 minus 3 times 2 minus minus 1 equals minus 4. The solution is right. So, I think in this place we cancel the introduction to the calculation, to the matrix calculations. its introduction will require further for investigate the properties of the vectors and many the rules of the lines in the space, the plane in the space, and it's required for further investigations. And during this week, I will send you by email a short home task on the topics of the previous seminars. You have to solve these problems, to write on the paper, scan in the PDF format, and send me return by emails. I had supposed to send the home task during last week, but at this moment I have not email address you, unfortunately. I will try to find it from the Dean office and to send you a textbook and to send you task home. I will try to do it not later than Wednesday.
The document, the book, please send the name of the book.
Yes, of course. I sent all, but I have not your email addresses, unfortunately.
We can take your email and we will send you a message from our email so you can.
Maybe, okay, maybe you have my email address? No? Yeah, you have my email address. You see, I repeat my email address. Kireenkov A.A. at fistech.edu. It's main email for correspondence, and second email Kireenk at ipmnet.point.ru. But please send your home task on these emails. To these emails. And in the topic of the letter, you have to write your name and number of your groups. I think simply group number 2. Yes. Write group number 2. Because on all groups from the Russian students, there are a long number with letters and numbers, but here simple group number 2 for indicate from what they have received a letter. Okay, thank you very much, but I think there are questions in the you see, I have not forgot to send us the book because I have explained I don't know the email address of you. And you see, dear Diego, I have not received a letter from you. Mr. Diego Alejandro, I have not received asking for you, unfortunately. Maybe there are mistakes in the email address. I don't know. Okay, thank you very much. Thank you for your time. And our seminar is finished.